Hello, today we're going to do day 2 of the quotient rule and product rule. Today we're going to use tables and graphs. Alright, so our first problem here is let f of x be mx times nx, and we want to find f prime of 2. So we first have to be able to take the derivative of f of x. And so what that's going to look like is our product rule, where we take one function times the derivative of the second function and add it to the derivative of the first function times the second function. All right, and if we're concerned at 2, we're looking for f prime of 2, we want to do all of this evaluated at 2. So we go to our table and we figure out what m of 2 is. If you see here, m of 2 is going to be 4. N prime of 2, again, stay with the 2, n prime is 2. And now we do m prime at 2. So I go to 2 still and stay at m prime, which is 1/5. And then n of 2, which gives me 1. We put these numbers together. 4 times 2 is 8. 1/5 times 1 is 1/5. And so my answer is 8 and 1/5, or 41/5. All right, let's do it again. Starting off with our g of x function is now the quotient of 2 functions. We're going to use the quotient rule. So I need to write out the rule first, is what I normally do. So I'm going to just write the rule right here beside it. So I say to myself, low d high minus high d low all over low squared. Helps me to write them out first, and then I just plug the 3 in. So I do g prime at 3 is going to be, I didn't need to write that again, n of 3 times m prime at 3 minus m of 3 times n prime at 3. All over n of 3 quantity squared. All right, now we just go use our tables and we go figure out what all these numbers are. So n of 3, so here I am at 3, and I go n of 3, which is 2. M prime at 3 would be -1. M of 3 is 3. And n prime at 3 is 1/2. All over n of 3, which we already said was 2 squared. All right, now all we have to do is calculate what these numbers are. -2 minus 3/2 over 4. Got some fraction work to do. This is the same thing as -4 halves minus 3/2, common denominator on top, which is the same thing as -7/2. Instead of dividing by 4, I'm going to multiply by 1/4. So my answer is -7/8. G prime at 3 is -7/8. All right, let's look at another one. Now we have a function given to us, 4x cubed plus 3x, times our table function, our m of x. So again, I would start off with just writing the quotient, or sorry, this is going to be a product because we're multiplying, writing the product rule. So I take one function times the derivative of the other function, and I add it to switch. So I now take the derivative of the first function, which is 12x squared plus 3, times m of x. All right, and now I just plug 1 in there, and I plug 2 in there, and I get my numbers. So if I put 1 in here, literally there's no table to look at. You just stick 1 in for x. Okay, now I have to go use the table to find m prime at 1. And so m prime at 1 gives me -6. Put parentheses there so it doesn't look like it's -6. And then I'm adding, and again, I just stick the 1 in for the x. And then I do m of 1, and m of 1 is 2. And so now I have 4 plus 3, which is 7, times -6, plus, I should use parentheses over here, that was incorrect, 12 plus 3, which is 15, times 2, which is 30. So then I have 7 times 6, -42, plus 30, and that's going to result in -12. Okay, why don't you stop the video and see if you can do h prime at 2. All right, welcome back. My answer I got was 211.6. Let's just check, make sure you did everything right. You plug the 2 in for the x. So it's 4 times 2 cubed plus 3 times 2. You find the derivative at 2 for m, and the derivative for 2 is going to be 1/5 now. So I have times 1/5 here. Plug in the 2 for the x on this derivative of the first function, and then go find m of 2, and you can see m of 2 is 4. And then it's just multiplying and adding together to get 211.6. All right. Again, if you've got the hang of this, stop it, pause it, see if you get the right answer, and start it back up. All right, so I'm going to start with h prime of x first. So I write h prime of x first, just so I practice my rules. So low, d high, the derivative of the top is going to be 2x, minus high, put it all in parentheses, d low, all over m of x quantity squared. Now I just plug the 1 in there. So I'm going to do m of 1 times 2 times 1 minus 1 squared plus 1 in parentheses, and m prime at 1 all over m of 1 squared. All right, then I just go to my table and look at what I got going here. So I got m of 1. M of 1 is 2. 2 times 1 is 2. 1 squared plus 1 is 2. M prime at 1 is -6. And m of 1 we said was 2. 2 squared. And so I've got 4 plus 12 over 4, or 16 over 4, which is 4. All right, now let's go away from tables and let's take a couple look at some graphs. Okay, same idea. Find what I would again write the product rule. So I know it's going to be the first function times the derivative of the second, or it doesn't matter which order you go. First function times the derivative of the second, and add it on to the derivative of the first function times the second function. All right, and then I just plug 1 in. So p of 1 times q prime at 1 plus p prime at 1 times q at 1. All right, so p of 1, this is my p function, so I go to 1, and my p value is 3. Now remember, the derivative is the slope of the tangent line. So at q of 1, we're not looking for that value, we're looking for that slope of that line, and as you can see, it's going up 1 over 1. So that is just going to be 1. P prime at 1, we're looking for the slope of this line, and it goes down 2 over 1, so my slope is -2. And now q of 1, again, go up to your graph here. Q of 1 is 2. And then we just put those numbers together. All right, and I got 3 minus 4, which is negative 1. Okay, why don't you go ahead and try the next one. Stop and restart the video. Okay, so g of 2 means, or sorry, j prime at 2 means I need to take p of 2 times q prime at 2 plus p prime at 2 times q at 2. All right, so I go up to p of 2, and I see that p of 2 is 1. So I put that in. And then I go to q prime at 2, and again, that's the slope of this line, up 1 over 1. And then I go to p prime at 2, so you're looking for the slope at that point. Uh-oh, that's a corner. Not a good plan, or not a good value here. This does not exist. And therefore, we're done. No more work. Does not exist. All right, let's try another one. Okay, now my function is e to the x times q to the x. So again, I'm going to write my product rule out. So it's the first function times the derivative of the second function, and I'm adding it to the derivative of the first function times the second function. And if I want to figure out what k prime at 3 is, everywhere there's an x, I stick a 3. So e cubed, g prime of 3, plus e cubed, q of 3. I'm sorry, I said g, I meant q. All right, so q prime at 3 is, remember, the slope. So you go up here, 1, 2, 3. What's the slope of this line? Still looks to be up 1 over 1. All right, then I have q of 3, which is that value there, which is 4. Okay, and then there's really, you want exact values. So if you want to, you could factor out the e to the 3, or you could see that those were like terms and just add. But if you need to factor it out to see their like terms, and you have 1 plus 4, which ends up being 5 e to the 3rd. All right, last one. Please stop it, give it a shot on your own. Restart to see if you got the right answer. All right, welcome back. So I started off with the quotient rule, as you can see I wrote there, and then I put in p of 6 and q of 6, and I put 6 everywhere there was an x. Now, this may require a little bit more work because p of 6, if I go here, it's not crossing at a really great point. But that is a line, and I know how to write an equation of a line given 2 points. So this is the point, and this is a point, so I would calculate my slope. My slope is rise over run, so I went up 1 and over 5. 1, 2, 3, 4, 5. And then I just do my point slope form. So I would write the equation as y equals y1, which is 1 plus my slope times x minus x1, which is 2. I'd go ahead and just distribute that 1/5 through and combine like terms, or now just put 6 in. So y equals 1 plus 1/5 times 6 minus 2. So that's 4. So you have 1 plus 4/5, which is the same thing as 9/5. All right, so that's where you're going to see where I got the 9/5 from. Then I'd find the slope at 6 here, but you can see the slope of the tangent lines are 0, so that's 0. Then I find q of 6. Q of 6 is 5. And then I find p prime at 6, which is the slope of this line, which we already found out was 1/5. And so then I plug those numbers in all over my p of 6, which I've calculated to be 9/5. 0 minus 1 on the top. Square that, and to deal with complex fractions, you never divide, you multiply by the reciprocal. So I ended up with negative 25/81. All right, that completes our lesson today. I would like you to continue to work on your assignments. Have a nice day.